Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we're going to be doing Unit 4, Lesson number 10 on logarithm laws. For the past few lessons, we've been exploring logarithms. We've been looking at just what they are, generally speaking. What do they evaluate? How do they evaluate? In the last lesson, we looked at their graphs, their domains, their ranges, limitations on the functions. Today, we're going to learn a little bit about the laws that logarithms play by, the rules, if you will. So let's get right into it. All right. Now, the key here is that logarithms are inverses of exponentials. So for every major exponential law, one expects a logarithm law. And let's take a look, because that's certainly the case. All right. The first law we look at is the product law. Now, in the exponent version, we've seen this many times. When you multiply two things that have the same base, right, the same base, you end up adding their exponents. X squared times x cubed is x to the fifth. The logarithm version, on the other hand, is when you take the logarithm, base b, of a product, you can then add the individual logarithms together. And vice versa. You can also move this back in this direction. Never forget that laws, or equality, are a two-way road. Okay? Now you also have the quotient, right? The exponent version is that when you divide two quantities with the same base, you subtract their exponents. Well, the logarithm version, no great surprise. When you take the logarithm of a quotient, a division, then you can subtract the two individual logarithms. And again, it also goes this way as well as this way. Finally, and a little bit probably the most important of all the laws, is the exponent version. When you have something raised to an exponent raised to another exponent, you can multiply the exponents. The logarithm law here, this is a little bit harder to see. When you take the logarithm of some quantity raised to a power, then you can literally bring that power out so that it forms a product. This might be the most important logarithm law. Maybe not in this lesson, but in future lessons we'll see where this one is going to help us out a lot. Okay? So the logarithm laws, and I will keep reproducing them page after page after page because you need to get used to them, and they can be very, very confusing. But a first exposure in Algebra 2, a follow-up exposure in pre-calculus will help you really get to know them. And they're really critically important both in the study of calculus, higher order math, but also in the study of a whole variety of different types and subjects of science. I'm going to clear out all the extra kind of writing I did, and let's move on and just do a bunch of logarithm law problems. Now, almost all the problems I have for you today are multiple choice, and I know that kind of seems a little bit strange, but to me, it's actually very, very helpful to be able to play around with these. So take a look. Exercise number 1. Which of the following is equal to log base 3 of 9 times x? Well, for this, what we're going to do is we're going to use the first logarithm law that says if I have a product, I can break the logarithm into the sum of the two various logs. So I can break this into log base 3 of 9 and log base 3 of x. Now, there's nothing I can really do with that. I'm kind of, if you will, done. But this I can actually do something with. Think for a moment about what the log base 3 of 9 is. All right. Remember, the log base 3 of 9 is whatever I'm going to raise 3 to get 9. Well, that's going to be 2, right? So this just becomes 2 plus the log base 3 of x, and that's choice 3. These two are the same. They're equivalent. All right? Let's try another one. Pause the video first, though, and write down anything you need to. All right, here we go. All right, exercise 2. The expression the log of x squared divided by 1,000 can be written in equivalent form as what? Well, this one actually involves multiple log laws. So we want to see the big structure. The big structure of this thing is that we're taking the log of a quotient. All right? So initially, the most important log law that kicks in is this one. And it simply says if we've got the log of something divided by something, we can do the log of the numerator minus the log of the denominator. Doesn't matter how complicated, that's it. Now if that's one of the answers, we pick it, but it's not. So let's take a look at this logarithm law. This will allow us to simplify this guy. This one says if we've got the log of a quantity raised to a power, we can actually bring that power out. So this will be 2 times the log of x minus the log of 1,000. And again, if that's one of my choices, awesome. I got two choices that look kind of similar, these two. Now, which one's right? Well, that really boils down to this. What is the log of 1,000? Remember, that's the log base 10 of 1,000. So what do I have to raise 10 to get 1,000? That's got to be 3, right? So that's going to be 2 log of x minus 3. Choice 1. Good? Pause the video now and write down anything you need to. All right, let's clear them out. Okay, exercise number 3. If a is equal to the log of 3 and b is equal to the log of 2, then which of the following correctly expresses the value of the log of 12 in terms of a and b? Oof. All right, let's bring this guy down here. Well, all right, let's start with this. Take a look at all the log laws. Every single log law deals with either a product, a quotient, or a power inside of here. Now right now all I have is 12. So maybe I'll break that into 4 times 3, right? Because then at least I could use the first log law. Okay, in fact, I could rewrite this as the log of 4 plus the log of 3. Now, one thing I know for certain is that this whole thing, is now equal to a. But what about this? Well, I know that b is equal to the log of 2, and this is the log of 4. But of course, 4 is 2 squared. I'm just going to put an a in there. Is that okay? I mean, that's what log of 3 is equal to. But now we can use that last logarithm law, pull the 2 out, and we'll get 2 log 2 plus a, right? Well, log of 2 is b. So that's going to be 2b plus a. And that's choice 4. All right. These are kind of fun once you get into them a little bit. Students typically like them. But it does oftentimes have to do with playing around with the expression inside of the logarithm so that you can get it to a point where you can use those logarithm laws. Have those in front of you at all times when you're working on the homework, okay? All right, pause the video now, and then we're going to clear out the text. Okay, here it goes. Next problem. Exercise 4. Which of the following is equivalent to the log base 2 of square root of x divided by y to the 5th? Okay, I think it's about time to turn you loose. So what I'd like you to do is pause the video now and make an attempt at this one. See which one of these things it's equivalent to. All right, let's go through it. Again, the big structure here is not the fact that you've got a square root or a y to the 5th, but the fact that we've got a quotient, right? So immediately, we can break this up into the log base 2 of square root of x minus the log base 2 of y to the 5th. All right, this one I can definitely use that last exponent law on. And I can just pop that 5 out front. So minus 5 log base 2 of y. But there's a lot of those, right? Here, here, and here. So the question is now, what do we do with this? Well, this law only works if the quantity inside the parentheses is written raised to an exponent. And what we should know now is that the square root of x is the same as x to the 1/2. So we can now bring that 1/2 out front. And we would have 1/2 log base 2 of x minus 5 log base 2 of y. And which one is that? That's choice 3, right? So we have to be prepared when we see roots, square roots, cubed roots, fourth roots, to re-express those as powers so that we can use that last logarithm law. Okay, pause the video now and write down anything you need to. Okay, clearing it out. Let's take a look at number 5. The log base 3 of root 5 divided by 27 is equal to, this one feels very familiar, very similar to the last one. Maybe there's a little bit of something different, but why don't you go ahead and try this one on your own. Pause the video again, and let's see what you can do. All right, no time like the present. Again, similar to the last few problems we did, the overriding structure of this problem is that of a quotient, and we can break that up into a subtraction. Okay, now this thing I can do something with. Log base 3 of 27 is 3, right? Because 3 to the third is 27. Here, I'm going to pull exactly the same trick I did before. Square root of 5 is the same as 5 to the 1/2. So I'm going to bring that 1/2 power out and make this 1/2 log of 5 minus 3. Now what I'd love is for that to be sitting here. And I got to watch out because I'd be very tempted to grab this choice. But that's actually not the right choice. In fact, I've got log 5 divided by 2 minus 3. That's going to be log 5 divided by 2 minus 6 divided by 2. And that's going to be log 5 minus 6 all divided by 2. Whoops. And then I lost my log base 3 along the way. Sorry about that. And that's choice 1. So don't forget about elementary algebra, right? Don't suddenly combine two things that don't have the same denominator. But there we have it. All right, pause the video, write down anything you need to, and then we'll move on to another multiple choice question. All right, let's do it. All clear? Oh boy, ooh. If f of x equals log x and g of x equals 100x cubed, then f of g of x equals what? So now we have function composition. It's been a little while since we've seen composition. But we want to try to figure out what this is equal to. Now remember, when we have f of g of x, what that means is that g of x goes into the input of f. So we're literally looking at f of 100x cubed, right? All I did was take the g and put it in here. But that means I must have the log of 100x cubed. Now, if that's one of my choices, awesome, but I don't see that one. So then the question becomes, well, what do I do? Well, the big structure here, and again, it's important to see the big structure, is a product. It is not the power. We can't bring that 3 out because the 100 isn't being cubed, all right? What we can do is rewrite this as the log of 100 plus the log of x cubed. In which case the log of 100, that I can do something with, right? That's 2, right? 10 squared is 100. And for this, now I can bring that exponent out, 3 times the log of x. So where do we have? There it is, 2 plus 3 log x. All right, combination of composition and log laws. Okay, pause the video now, write down what you need to. All right, let's get rid of all this annoying text. And let's move on to exercise number 7. This one's starting to get tough. Log base 2 of the square root of 32x to the 7th. Well, take this as a challenge. Pause the video now. See what you can do with this one. All right, let's go through it. So, it's somewhat hard to see what the big structure is here. One thing I know I can do is I can rewrite that square root symbol as a 1/2 power. So I'm going to write this as 32 x to the 7th all to the 1/2. Now, that means I can use that final logarithm law. I can bring the 1/2 out. 1/2 log base 2 of 32 x to the 7th. All right, well, that's good. All right, I want to be careful about that 1/2. Maybe keep it in parentheses. Now the structure inside of here gets me to a product, right? I have the log base 2 of 32 plus the log base 2 of x to the 7th. Keep that 1/2. Log base 2 of 32, I can do something with that. That's 5. 2 to the 5th is 32. Here, I can pull that 7 out. Plus 7 times log base 2 of x. Now, of course, multiplying all of this by 2 is exactly the same as dividing by 2. So I get this as my final answer. Choice 2. And I even ventured into the black. Whee! The black margins. All right, so pause the video now and write down anything you need to. Okay, let's clear out the text. Okay, that's gone. Let's take a look at exercise number 8. See where we're going with this. All right, strangely enough, this one seems really easy, but students tend to really struggle on this. So yet again, I'd like you to take a look at it, read through the problem actually on your own, and see what you can make of it. Okay, let's take a look. If the log of 7 is equal to k, then the log of 4900, apparently I just cleared the page again, can be written in terms of k as what? Wow. All right, well, let's take a look at this log of 4900. All right, by the way, did you notice we're log base 10 here? What's definitely clear to me is that 4900 is the same as 49 times 100. Now that's good because that immediately allows me to use the first log law. So I can rewrite that in terms of log 10 of 49 plus log 10 of 100. Okay, now this, again, I can do something with. That's equal to 2. But what do I do with this, log base 10 of 49? Well, 7 and 49 have a relationship, right? And that relationship is the fact that 49 is 7 squared. But once I write it like that, I can then pop that exponent out and get 2 log base 10 of 7. But log base 10 of 7 is equal to k, so this is 2k plus 2, or in factored form, 2 times k plus 1. So choice 1. All right. Lots of students have a hard time with that because that 4900 is so large that they kind of look at it and don't exactly know what to do with it. But starting to break it up into a product so we can use that first log law, it's a good start. All right, pause the video now and write down anything you need to. Okay, get rid of it. And let's take a look at the last exercise. Finally, we have one that's not multiple choice. Exercise number 9 says, consider the expression log base 2 of 8 to the x. It says, using the third logarithm law, the product law, rewrite this as an equivalent product and simplify. All right, so go for it. use that last law, that law that says the log of x to the y is equal to y times the log of x. Go for it. All right. Well, it's not very hard. If we have the log base 2 of 8 to the x, what that logarithm law allows me to do is bring the x out. I'll get log base 2 of 8. But this is 3. So all of this is 3x. So this thing and 3 times x are equivalent. Isn't that amazing? Now letter B says test the equivalency of these two expressions for x equals 0, 1, and 2. All right, well, let's do it. For x equals 0, right, and x equals 0. Over here, let's do the logarithm. Here, I'd have the log base 2 of 8 to the 0, which would be the log base 2 of 1. What do I have to raise 2 to get 1? I have to raise it to the 0. Over here, I'll try the 3x, and of course 3 times 0 is 0. So it works there. Let's try x equals 1. Here I'll have the log base 2 of 8 to the first, which gives me the log base 2 of 8. 2 to the what gives me 8? 3. Over here, x equals 1. For 3x, I'll just get 3 times 1, or 3. Okay, that checks. Let's do one more. X equals 2. Over here, I'm going to get log base 2 of 8 to the second. Gives me log base 2 of 64. Now this is a little bit harder. 2 to the third is 8. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth is 64. And of course over here, easy enough. 3 times x, 3 times 2 is 6. So it checks. It's amazing that log base 2 of 8 to the x is such a simple expression, 3x, and yet it is. Now, one last thing. It says, show that log base 2 of 8 to the x is 3x by rewriting 8 as 2 cubed. In other words, forget about the logarithm law. 8 is equal to 2 cubed. All right? So really, I have 2 cubed to the x. That's not really what this is. Don't worry about this right now. Don't worry about that. Okay? But using the exponent law that says something raised to an exponent raised to another exponent is their product, I can do this. But then by definition, the log base 2 of 2 to the 3x must be 3x, because ultimately if I'm asking what do I raise 2 to get 2 to the 3x, well, then the answer must be 3x. Isn't that cool? Totally different way of looking at it. Well, maybe not a totally different way. All right. Pause the video now, write down anything you have to, and then we'll wrap up the lesson. All right, here we go. So today, we looked at what are known as the logarithm laws. If you ask anybody, whoever has taken Algebra 2, I don't care which version of it, Common Core, Algebra 2 with trigonometry, Math B, there's lots of different names it's gone by over the years. They've all had exposure to log laws. Log laws today were just a kind of thing that we were getting used to, manipulating multiple choice kind of questions using them. But eventually logarithm laws allow us to do all sorts of things, including solve equations that involve logarithms, solve equations that involve exponentials, we'll be doing that, and really manipulate expressions that have logarithms in them to make them easier to deal with. For right now, we just really want to have exposure to the laws so that they're not brand new when we really need them. Okay, for now I'd like to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.